Hello mathematicians, let's have a look at trig identities. So first of all, what is an identity? Well, it's simply a relationship between trig functions. So we've encountered a few so far. The first ones we came across were the reciprocal identities. So that was cosec, which was the reciprocal of the sine ratio. Sec, reciprocal of cos, cot, reciprocal of tan. So it's simply how these are related to each other. We also saw the complementary angle identities, which you would have encountered in junior school, where cos of theta is the complement of sine of 90 minus theta. Cos is the complement of sine, so cos of theta is sine of 90 minus theta. Likewise, cot is the complement of tan, so tan theta is cot of 90 minus theta. And cosec is the complement of sec, so cosec of theta is sec of 90 minus theta. We've also encountered the tan identity, so this will be really commonly used by us, that tan of theta equals sine of theta divided by cos of theta. Now, also commonly used are the Pythagorean identities, and these arise from our unit circle definition. So you'll remember the unit circle was x squared plus y squared equals 1, and when we were working up our alternative definitions of the trig ratios, we said that sine of theta was equal to y, cos of theta was equal to x on our unit circle. So that simply gives us that x squared plus y squared equals 1 becomes, so we get sine squared theta plus cos squared theta equals 1. Now there are two other relationships which we can get from that. So we really only have to remember this one, although it is given on your reference sheet. And this one we know simply because we know the formula for a circle. So again, it's that combination of these little facts which sure there are memory aids too on your reference sheet, but if you can get them automatically, so much the better. So this one should definitely be automatic. These ones are a quick derivation. So if we took our sine squared plus cos squared theta equals 1 and we divided through by cos squared, you can see that sine squared divided by cos squared will give us tan squared. Cos squared divided by cos squared is 1, and 1 divided by cos squared is sec squared. So that's our second Pythagorean identity. And the last one is if we divide our first one by sine squared. So sine squared divided by sine squared is 1. Cos squared divided by sine squared, that's our upside down version of this, so it's cot squared. And 1 divided by sine squared is cosec squared. And the reason it's typed like this is simply because the formula in a formula maker in Microsoft Word only allows 3 letters. So no need to write it like that, just write the full cosec. Okay, so if we're going to work with these identities, the most common question is that we have to prove an identity, prove a trig identity. And as we've mentioned in class, setting out is really important so that we reflect the logic of what we're doing. And this is essentially the process. We take one side, usually the one that looks the more complex, and we simplify it by these steps. So we look to see if there are any identities. So any of the things that we've just mentioned. We usually convert inverse ratios to sine cos tan, and we often write tan as sine over cos. So if there are squares, there's a fair chance that we'll be using one of these. If not, we're going to be looking for these. Occasionally, they might bring a complementary relationship in. So let's have a look at these, and I might occasionally skimp on the setting out because of lack of space. So for the first one, prove this. Well, I take the more complex identity, which is the left-hand side, and I want to make it equal to sine theta, the right-hand side. So I look at it, there are no squares involved, there are no reciprocal ratios involved, but there is a tan. So if I write that as sine theta over cos theta, and that's being multiplied by cos theta, you can see that they will cancel out to leave me with sine theta, which is the right-hand side. A nice one to start with. Our next one, cot times sine equals cos. Again, for this one here, left-hand side is slightly more complex. Cot I'll write as cos over sine, and you can see as you write that this will turn out to be okay, so it's the right-hand side. And our last one here, again, left-hand side, sine, nothing we can do with that, but sec is 1 on cos, and now we know that sine over cos is tan, so that equals the right-hand side. I should really make that explicit, so I should say equals tan beta. So just be careful. Treat the examiner like an idiot and you'll be on the right track. Okay, next one. Prove this identity, that cosec times sec is 1 on sine times 1 on cos. Now, which side is the more complex? Who knows here? But I'll start with the left-hand side simply because I don't like fractions. So my left-hand side, 1 on cosec is 1 on sine, and sec is 1 on cos, and we can see then that that is 1 on sine times cos by our knowledge of fractions. So it equals the right-hand side. Our next one, cosec squared plus sec squared equals this thing. We've probably got a few options. Again, which side will we start with? Well, this is probably in a way a little bit more complex, but I'll start with the left-hand side and see how we go. So cosec squared, now because of the squareds, I look back to my relationships from up above. And since I can't scroll the page easily, this will give us a chance to practice that thing. So I know that sine, and this is really just working, don't ever set it out like this. Sine squared plus cos squared is 1. If I divided both sides by sine squared, this will give me 1 plus cos on sine, which is cot squared, is 1 on cot squared, which is, 1 on, lost my train of thought now, sine squared, cos squared on sine squared is cot squared, 1 on sine squared is cosec squared. So if I divided through by cos squared, I could have 1 on, sine squared on cos squared is tan squared, cos squared on cos squared is 1, and 1 on cos squared is sec squared. Now, there's nothing too promising that I can see which I could use to directly replace these. So I'll take another approach. Cosec we know is 1 on sine. So if I write that as 1 on sine squared, and sec is 1 on cos, so I'll write that as 1 on cos squared. Now, I know whenever I have fractions that if I get the common denominator, so that would be sine squared cos squared, and you can see that you start to feel you're on the right track here. And up the top, sine squared goes into this cos squared times, so that's cos squared times 1. Cos squared goes in sine squared. We know we're there because sine squared plus cos squared is 1. So done. Now this next one we could tackle in a few different ways. We would start with the left hand side because it looks a little bit more complex, and write our cot as cos over sine, cos x over sine x. and write our tan as sine over cos. Then we're really working with fractions here, so let's put all of those over a common denominator. So that will be sine x plus cos x over sine x, and cos x plus sine x all over cos x. If we then realise that this is one fraction divided by another, then we know that we would invert and multiply. So sine x plus cos x on sine x times cos x over cos x plus sine x. We can now see that cancel with that. We're left with cos over sine, which is cot. So setting it out, left hand side equals that thing, which somewhere down the track equals the right hand side.